This is the second video for Module 7 for Secondary 2 Honors. We are going to continue simplifying rational expressions. This time we'll be multiplying and dividing expressions. So in order to multiply and divide rational expressions, you are going to use factoring and other simplifying skills to multiply and divide rational expressions. You need to know how to tell if a rational expression is simplified completely, and you need to know how to simplify a complex fraction. Steps to multiplying rational expressions: you just factor each part of the rational expression if possible. Look for matching factors. Remember, don't cancel terms, just cancel factors. And after you've canceled matching factors, you can multiply what's left together if it looks like that would be a good thing to do. It's kind of optional. Okay, so for example 1, in order to multiply this rational expression, you notice that we've got this rational expression right here times this rational expression. So we're multiplying those two together. So the first thing we're going to do is we're going to factor the different parts of this. So I'm going to take the x squared minus 25, and it's a difference of squares, so I'm going to factor that to x plus 5 times x minus 5. And then the bottom of that is x squared minus 5x plus 6, and so I'm going to multiply, or factor that. And that one is going to be x minus 3 times x minus 2. Now you might think, well, I don't see anything that factors or that cancels, and so what's the point? But we're not done yet. So the next thing we're going to do is now we're going to go over here to this other one, and we're going to take x squared minus 4, and we're going to factor that. That's a difference of squares. And then our denominator, x squared plus 2x minus 15. Okay, and so that's what we've got. So when we multiply all that together, if you remember how you multiply fractions, remember that you just multiply across the top and across the bottom. So what we have is we have x plus 5 times x minus 5 times x plus 2 times x minus 2. That's our numerator. Then our denominator is x minus 3 times x minus 2 times x minus 3 times x plus 5. And so I can just look at that and I can just simplify by canceling anything there, because when you multiply it's commutative, so it doesn't matter what order. So I could rearrange suiting whatever I want it to do. So I've got x plus 5 cancels with x plus 5. My x minus 2 cancels with x minus 2. And I don't see anything else that is common. So what I have left then is I have x minus 5 times x plus 2 on the top over x minus 3 times x minus 3. Now you can leave it like that, but usually it probably looks better to go ahead and multiply that back together, so using your distributive property or your FOIL method. So you can multiply that back together as x squared minus 3x minus 10, and on the bottom you're going to have x squared minus 6x plus 9, and so this is our simplified rational expression. Okay, dividing rational expressions, if you remember how you divide fractions, we're going to use the same principles there. You're going to change the division sign to a multiplication sign, like when you divide fractions. You're going to change the second rational expression to its reciprocal. You do not change the first one. And then you just multiply just like we just did. So in this example, we're going to start with, again, factoring what we can. So x minus 4, and then x minus 2 quantity squared. I'm going to write that out as a product. Okay, and then what I'm going to do is I'm going to take this division sign and I'm going to change it to a multiplication sign, and then to make up for doing that I'm going to switch and get the reciprocal here. So x squared minus 4 over x squared minus 3x minus 4. Okay, then I just have a multiplication problem, so now I'm going to go back to getting ready to multiply. So I'm going to factor everything that I can. This is the difference of squares. Okay, so now I'm going to multiply that, and so remember, just across the top and across the bottom. So x minus 4 times x plus 2 times x minus 2 over x minus 2 times x minus 2 times x plus 1 times x minus 4. And I see some common factors, x minus 2 and x minus 2, x minus 4 and x minus 4. There's nothing else. And so I'm left with x plus 2 over x minus 2 times x plus 1. So here again, you can leave it like that, but usually it's probably a better idea. It looks neater if you put it all together. So when you multiply it all out using your FOIL method, you will get this polynomial, this rational expression. Okay, so now what is a complex fraction? It's kind of just what it sounds like. It's a fraction that looks complex. A fraction that contains one or more fractions in the numerator, the denominator, or both. So basically it's a fraction within another fraction. So as an example, we've got this example 3, so you notice that our numerator is a fraction and our denominator is a fraction. And so the way that that looks, it looks really intimidating, but if you just think about what it means, it's just really the same thing as what we just did. So if you just say it's x plus 2 quantity squared over x minus 3 divided by x squared minus 4 over x minus 3 quantity squared, and now you can just do the same thing we did on the last problem. So factor everything that you can. So I'm going to have x plus 2 times x plus 2 over x minus 3. I'm going to change my division to a multiplication sign, and I'm going to get the reciprocal for this right here. So I'm going to have x minus 3 times x minus 3. Then the x squared minus 4, that's a difference of squares, so x plus 2 times x minus 2. And then I'm going to multiply it all together. And then I look for common factors. So I see a common factor right there. I see a common factor right there. That's all. So I'm left with x plus 2 times x minus 3 over x minus 2. So simplified or factored out or written out, multiplied out, you're going to get that. Okay. The next one that we're going to do, I'm going to have you pause the video and I want you to work this one out just like we did in the previous example. So remember, separate it, just deal with each little piece at a time, and then divide it, and then come up with your simplified, and then press play and see if you get it right. Okay, so x plus 4 times x minus 4 over x minus 3, and then this division, you can write it like this. You want to be careful that you don't do too much at one time, but at the same time you don't have to write down every single little thing. So when I'm writing this, I'm going to be really, really careful, but I would probably, instead of writing all this in the first step, I probably would have just written multiply and then factor it and write it out as I go. But it's kind of up to you. You have to know if you're able to do that or not. Do you have enough experience? Do you feel like you're comfortable enough doing that? So now I'm going to multiply everything together. And look for common factors. So you should have canceled that. Can you notice that we have 2 factors left on the top? I don't have anything left on the bottom, so it's over a 1. We don't have to write that, of course, but just know that that's what it is. And then so when I multiply that together, that's what I'm going to get. Okay, example 5. This one has a multiplication problem and it has a division problem as well. So this one's pretty complicated. There's a lot going on. You kind of want to pick what you're going to do first. The first thing I would do is I would take this fraction right here and I would just simplify that one. So I'm just going to concentrate on that first. So I'm going to have 2x minus 1 divided by x minus 6 divided by x minus 2 over x plus 2. So if I write that as a multiplication problem, and you see there's nothing that I can simplify, and so you might think, well, why do that? Well, we're going to do that because now I'm going to throw in this part of the problem. So now what I've got is x minus 6 times 2x minus 1 times x plus 2, x plus 2 on the bottom times x minus 6 times x minus 2. And so now I can look for things to cancel. So I've got this one, and I've got this, and so what I'm left with, is 2x minus 1 over x minus 2. So from that really ugly rational expression, we have something that doesn't look too bad. Okay, the last example. Again, another complex fraction. I want you to pause the video and work this out as much as you can, and then come back and check and see how you did. Okay, first I would simplify this part, difference of squares, greatest common factor. I'm going to multiply by the reciprocal of this, so I'm going to be moving that around as I'm factoring. So the x plus 5 is going to go on the top, then I'm going to factor this on the bottom. Okay, and then if I write that all as one product, oops, you can simplify right here. You could take this away and this away, and it just kind of makes the rest of the problem a little bit easier, so I think I'm going to do that. And then I'm going to multiply by the x minus 4 over x minus 7. You want to be careful not to forget any of the pieces. Obviously that could make a big difference. And so you're going to be left with x plus 5, and then the 3 is going to be written out in front. You could leave it like that. That would be perfectly acceptable actually, but if you would like to, you can go ahead and multiply that. Just don't forget to distribute everything. And that's the answer that you should have gotten. Okay, you should now be able to complete numbers 22 through 27 on the practice worksheet. If you need help, please come in and get some help with your teacher, and come and check your answers to make sure that you're doing it right if you have any questions.